Hello everybody, my name is Michael from St. Louis, Missouri in the United States. I have 5 years of experience building applications in JavaScript. In the past I've built an animal behavior logger and another application called Doggos for World Peace in JavaScript. In this project we are going to build a whack-a-mole game with A-frame. This is going to be a very fun project. If you want to learn A-frame or for any matter any sort of technologies, the best way to learn it is by hands-on learning, so by building projects. So, what are we going to be doing in this project? Alright, so in this project we're going to be building a whack-a-mole game. What this means is that it's just a game and it's going to be in virtual reality or WebVR. So it's basically a game where you're in like one place and you look around, and when you look around to certain areas there's moles, and if you look at them for a certain period of time then you get to whack the mole, and the goal is to whack as many moles as you can in the shortest period of time possible. So you have a timer like 15 seconds. You gotta whack as many moles as you can. So just a fun little game in virtual reality. So what are we gonna use in this? We're gonna be using HTML, CSS, JavaScript. You're gonna need to know some Node.js and maybe some basic knowledge of the terminal. We're also gonna be, and the key main component we're gonna be using is we're gonna be using A-frame. A-frame with just some ES6 JavaScript. The streaming schedule, all of it's pre-recorded, so just check back every once in a while, and there's going to be more and more sessions. There's going to be a total of 4 sessions. So within the first session, it's just going to be environment setup. We're going to install the dependencies, set up Webpack, run the web server to run the WebVR game, and then we're going to run the A-frame example that they provide on the A-frame website, right? For the second session, we're going to be doing world design, so we're just going to design basically the skeleton of how it should look, right? So it's going to have the mole holes, the moles themselves, and then the hammer that the player is going to use to actually hit the moles, right? And then we're going to have the actual whack-a-mole core mechanisms, and that's going to be session 3, where we're going to programmatically have the rats pop up, or moles pop up at different intervals. We're going to have a scorekeeper like UI, so that when you whack a mole it increases the score, and then we're going to also animate the hammer, so that when the mole is hit then the hammer goes down, right? And then on session 4 we're going to tie up some loose ends. We're going to add a game timer. We're going to present the user with the amount the score that he has after the timer ends, and then we're going to add the ability to replay the game continuously, basically. So that's basically this project in a nutshell. It's gonna be a whack-a-mole game in WebVR with the A-frame JavaScript framework. If you guys are interested, please be sure to stay tuned and watch the sessions as I release them. So yeah. Hello everybody, and welcome to the first session of how to create a whack-a-mole VR game with A-frame. So in this session, we are going to be setting up the environment. So what that means is that we're going to be installing dependencies, setting up Webpack, running the web server so we can view it in our web browser, and then running the basic A-frame example. Alright, so first we're going to start off by installing our dependencies. So for this project we're going to install a couple dependencies. You may or may not have heard of some of them. So we're going to install Lodash, Babel, Webpack, and then we're going to also, for our web server, we're going to also install Live Server. So first we're going to install Webpack and then Babel. So we're going to type npm install -d Babel loader, Babel core, Babel preset Webpack, and then Webpack dash CLI, it's very important that you have the dash D for it. So we're gonna run that, right? And that will install those dependencies for us. And it shouldn't take too long, I think. Okay, and then after that, we're gonna install Lodash by npm install save Lodash. Right, so that's just a utility library for when we're composing things in A-frame. And then the last thing is we're going to install live server. So we're going to do npm install save dev live server. And for you to be able to do any of this stuff, you have to make sure that you have empty folder, you have Node.js installed, you have Node package manager installed, so that way you can install these packages for the project. And then I think, did we install Lodash? Okay, I think after that we have all our dependencies saved. So now we can go into our folder with our project, or where we install the dependencies, and we'll find that there is a package lock.json, but we also we still want a package.json. So you have to make sure to go in here and type in npm init and just hit enter the whole entire time. Now if you go back, we have a package.json, and it will list off all the dependencies that we installed, including the dev dependencies, right? Dev dependencies, it doesn't know about that, so we're going to move some stuff around so it knows exactly what we're talking about. So for dev dependencies, it's basically, okay, we have to rerun some of these commands so it works correctly. So you want to delete all of this, right? And we're just gonna rerun this command. We're gonna rerun that command so it saves correctly. Then we're gonna rerun this command. And then we're gonna rerun this command. So basically, before you run any of the installations, you want to make sure that you type the command npm init, so that way it actually gets saved correctly. So now if we go back, it'll have all the stuff in the right place. So you want to have dev dependencies, Babel, that preset env, Babel loader, live server, webpack CLI, all of that stuff, right? And then in just your regular dependencies, you're gonna have Lodash, all right? So that's so that was all of our dependencies, right? So now we're gonna set up what is called Webpack. What Webpack basically allows us to do is it allows us to take the newest version of JavaScript, or takes any sort of asset files, and it allows it can apply transformations and bundle it and stuff like that. So just for testing purposes, we're gonna create two folders. One's gonna be called public. Eventually we're gonna populate these later, but one's going to be called public and another one's going to be called JS. Within the JS folder, we're going to create a file called main.js. You'll see why in a second. And in this one, we're just going to have get keep and then index.html, because this folder is where we will be hosting our web application. We don't actually need to get keep, by the way. But now we can actually go out and configure Webpack. But before we do that, we should probably set up some helper or utility scripts. So in the scripts key in our JSON file, we're going to have two extra scripts. We're going to have one called Webpack, which just runs the Webpack command. And then we're going to have one called Server, which runs this live server from the public directory. And then after that, we can actually go right-click, create a new file. We're going to call it webpack.config.js. I'm using the text editor Atom. You can use whatever other Atom, whatever other text editor of your choosing, as long as you can create files, create folders, stuff like that. And then we are gonna import path. We're gonna import Webpack itself, right? And then we're inside the exports for this file, we're gonna tell it that it's of the development environment, that we are watching the files. So that means that if the files update, it will recompile everything. Our entry points main.js, our output. So we're looking at main.js from the JS folder. What we want to do is that, I'll type this up real quick. We want it to create inside the public folder. We want it to create a file that's of dis.main.bundle.js. What this does is it creates a file inside the public folder that's inside the dist folder, and it'll be called main.bundle.js. It'll become more evident what this does once we run the command. And then in order to have it compile to Babel, we're gonna implement some rules for the file transformations. This is gonna test for any JS file, but we're gonna use a little bit of regex for this. It's gonna exclude basically, and I'm going to copy this so because it's a little bit of a hassle to write. It's going to exclude anything from node modules or the Bower components folder if we were using Bower. Then it's going to use the Babel loader that we installed, and for the presets, this is going to automatically find the newest version of JavaScript and then compile it down to anything like ES 2015, right? So this is, at Babel preset M, right? Then we're going to add some extra stuff. We're going to add a stats thing, and the colors are going to be true. And then we're going to add the dev tool for creating source maps, so we actually know what happened when we created that bundle, I guess. So that's our Webpack file. I know it's pretty confusing, but this is essentially what you need to have, so that way when we run npm run webpack, well, let's see what happened. Okay, as long as you have the comma, all the commas, everything's formatted correctly, what will happen is that it'll compile from this whole thing, right? It'll compile from the JS directory, the main JS file, and anything that file imports, or any dependencies of that main.js file, and then it goes and transforms it and compiles it down to ES 2015, or the version of JavaScript that all browsers currently support, and it puts it in the dist folder as main.bundle.js, and then main.bundle.js.map is just a source map just for debugging purposes. So that was setting up Webpack, and then now we want to be able to run our web server, and just a simple test we can do is doc type, right? This is our base HTML, right? The title head tag, right? Body tag, and we're gonna have it have a title of whack, like that. Okay, and then we're gonna just be like, welcome to the game, just for testing purposes. So when we go back here, and then we, instead of running the Webpack command, when we run server, right, it'll pull up our web application within the web browser. So right now it just says welcome to the game because that's all we wrote in the index.html file, right? So now the final thing that we have to do, right, before we're basically finished with this session, is now we need to be able to run the A-frame example. So if we go to A-frame and we search, if we go to the A-frame website and we go to getting started, right, there's this sample, which is basically the base example for A-frame. So we have a script and then we have a scene. So we just have to copy this script tag, right? And put it in our head tag right here. And then we have to just copy all these elements that make up the scene. So we just copy that, put it in here. And what A-frame does is it has specialized components that, like a scene, all this stuff, like isn't really normal HTML, but JavaScript, this A-frame.js will look and find this A scene thing, and it will decompose it into and render it in a WebVR environment. So when we go back here to our game, when we have the live server running, so when we have the server that's watching for changes to the HTML, right? What happens is now we have, you know, the thing right here. So it's pretty nice. Yeah. So that's the system for that. It's pretty nice for sure. So right here, that's your environment. So if you just look into this a little bit more in depth, we have a box, a sphere, a cylinder, a plane, and a sky element, and these are all wrapped around a scene element. Now if we go back, as we can see, there's a box, a sphere, a cylinder, a plane, and a sky, and that's this color sky is a sky, and they even specified the color within the color attribute. So that's basically that's the bare minimum setup required, at least if you want to use A-frame along with ES6 and then have some pretty features like live reloading. This is one of the base setups to get that up and running if you're doing it from your computer and you have Node.js installed or npm installed. So that's that for this session, right? We covered everything that we needed to cover in this session. You know, you have to make sure you have a Webpack. You have to make sure that you have all your dependencies installed, and you have these utility scripts and the main.js and then the index.html within the right configuration, and then you get this. So that was this session. In the next session, we will be doing the world design. So we'll be actually designing the actual world in which the player will be, where the player can where there's going to be the holes for where the moles will be popping out of. They're going to be on the virtual table, and we're also going to render a hammer in the player view. So you know how in like so usually in some VR games you have like hands or whatever. In this one you're going to have like a hammer, and that's going to be your like hand basically, right? So that's going to be the next session. I hope you guys enjoyed the introduction to this tutorial project. Please make sure to stay tuned for the following sessions. So yeah, see you guys. Hello everybody, and welcome to the second tutorial for how to create a Whack-A-Mole VR game with WebVR and A-frame. So first thing I'm going to do, I'm just going to run the what we have so far. So we just run Webpack, and then in a separate tab run the server, and it'll open it up. Okay, so here is what we have so far. Okay, so we're gonna take this and we are gonna turn it into the actual elements that we need for the world so that it works correctly, right? So what we're gonna do first, or what we need to do first, is we're gonna have to download some stuff, models, 3D models for our game. So we're gonna have three 3D models. So we're gonna have a tree, a rat, hammer. Well, actually, you just need the rat and the hammer. If you can download the tree and put it in if you want, but I'll just show you how it goes basically, because I'll just show you what we can do with the tree. Okay, so you download it from Google Poly. So like you just search for tree, Poly, Google, whatever, right? Download it as a GLTF file, right? And say okay, whatever. Download. So you download each of them as GLTFs, right? And then in our code, you want to create a new folder, call it assets, gonna do and then models, and then you can do tree folder, rodent folder, and hammer folder. So I mean, just to reiterate, we're just getting all the 3D models, and then we're placing how the world environment's gonna look in the end, or at least the rough outline before we start animating things, basically, right? So, right. So I'm just gonna take all the models that we had. I'm gonna grab them here. I'm just gonna extract them into our folder. Well, actually, I'll just copy this one, and I'm just gonna copy this into the tutorial folder here. Okay. I'm just gonna extract them into the respective things, basically, and just, yeah, and then put in the right file. So these two would go here. So that one isn't needed. This would, these two would go here. So that one's not needed. Then we extract the final one. Right. Then we take these 3, put them in the tree folder, and that's that. So now if we go back into our code, we have the new folders, right? And basically what we want to do is we want to create a thing in our A scene called A-assets, right? And this is where all our 3D model, all the references to our 3D models are. We can delete each of these for now, right? So that way, this is our scene. Also, one little thing that we want to do as well is we want to just change the plane to be where it's 8 by 8 for the width and height. So you just change the 8 width from 4 to 8, and then the height from 4 to 8, right? So that makes it a bit larger to work with. And then what we do is we just import them, right? Import our assets. So we'll have the rodent model. So you use a asset item, the ID of it. I'll call it rodent model. I'm going to close this, right? And you just say, okay, here's our asset, and then here is the path to it. So in this case, that would be /assets models rodent, and then we call this rat. So this would be rat01 GLTF, because we're just referencing to the GLTFs of this. Same thing for the tree model, like this, and then the hammer model, like this, and make sure to call them their respective names, and make sure the path is correct. So in this case, it would be like so, right? Yeah. And so each of these is referring to the specific structure or directory where these models are stored. We're saying that whenever we want to refer to these assets, we'll use the ID that we assign to these. And then we're going to add these mix-ins, and these are just things that make adding these models in a lot more easier. So that we can pull in the specific model just by referring to the component, or the mix-in component. So you just say a-mixin, the ID of the mixin, we're going to call it rodent, then the model we're referring to, right? And since we already established what those are, we can just refer to them by their ID. So this would be rodent model, then we end the mixin, right? And then we can just do that for the rest of them. Okay, so now let's go here. So nothing has changed yet, but we have loaded the stuff in for that. Alright, so now that we loaded the models in, I'll just show you what it looks when you actually import one in, right? So let's do the rodent, right? So you just say mixin equals rodent, end it, and then just say what the position is. Guess it's over here. Then if you go back to your thing, you look around, now you have this really large rodent behind you, right? Pretty cool. So that's how you'd refer to it. You refer to it by its mixin name without that hashtag though, right? Like that. So pretty simple. So what we want to do for interaction purposes is we want to integrate a camera where you can only look around. So basically you can't move around with the keyboard, because eventually this is going to be, you're going to view it with a VR thing, right? So we'll do a-entity, give it the camera component, give it a position of 0, 1.6, and these, I think the distances are in, or the position is basically in meters, so 1.6 meters like average height of a human more or less, right? We're gonna make it look controls. We're gonna have it where its pointer lock enabled is set to true, right? Close this out. So now when we go back, put our mouse in, now our mouse disappears, right? Let me fix my mouse for a second. Okay, now, you know, that happens, right? Pretty cool. So then what we want to do is actually put two things. That we want to put in our hammer, right? And we're going to put in our hammer like so. I'll show you in a second once I paste a specific snippet in, right? That I wrote earlier. So we're going to have it where it's positioned at 0.075, negative 0.05, negative 0.1, and that scale of 0.01, 0.01, 0.01, and then it's going to have the mixin of hammers, so it's the hammer model, and then, you know, the closing tag. So now, go back, now we have our hammer, right? But we don't know where our hammer is aiming, so this is when we have to add the ring to it. Now, right now this ring is kind of weird, but we can mess with it later on. But for all intents and purposes, this is the one we're going to be using. And I mean, we can make it much more prettier later, though. That's the thing. So we're going to have a scale of 0.05 on all of them. Cursor, which has fuse enabled. And fuse basically means if you stare at it long enough, right? Then, you know, then it's gonna enable or trigger. And we're gonna have this have a position of 0, 0, -1, a geometry of ring, basically. So it's gonna be cursor, which is our ring. We're gonna have make it black. We're gonna add a flat shader to it, right? And then, so now if we just look here, there we go. Obviously, we didn't specify the color, so we have to just do, well, I believe we specified the color. I might be wrong though. Color. Might be completely wrong on that. There we go. Okay. So now we have a black cursor. There's animations that go along with it, but I'll add those animations later because we don't need them right now. The one that I could add, which is pretty useful, is this this cursor fusing thing. You can also pull these from the A-frame official documentation as well. So this is a little animation when the cursor begins fusing, right? Because this will hit the emit event, then ease in, have it scale, and make this do for maybe 150 milliseconds. Do it back, like whenever it finishes revert backwards from scale of 0, 0.0, 0, 0.1, 0, 0.1, 0, 0.1, etc. down to 0, 0.05, whatever, right? So that's the animation. So what happens, you know, for all intents and purposes, well, yeah, you'll see. So you stare at something long enough, it'll animate, I think. Well, you'll see it later on though. But that's what we have here. So that's our simple cursor, or camera cursor navigation. Now we're gonna add our table. So this table will be a entity with a scale of 3, 1, 2. So 3 on the X, 1 is on the Y, and then 2 on the Z. Positioned at, well, and then position is at 0, 0, and then -2 on the Z-axis. Material is going to be where it is just the color brown. And we're going to give it a geometry of primitive, and then box, right? So now if we go back, there we go. Here's our box. And you also want to make sure to close your entity so it doesn't mess up with the rest of the A-frame. So now we have our little box right here, right? Pretty nice. We can play with it, right? But it doesn't have anything on there. It doesn't have any holes to whack the moles with, so we have to do that real quick as well. So this is for our holes, right? So we'll have a parent or empty component, or with no like stuff in it. This will have the ID of holes, so we can refer to it later. So this is just like a component with like basically no, this is an entity with basically no components except for position and this ID, and then we're gonna have it where we have a hole like this. So basically it's positioned like 1, 0, 0.5, materials color black, scale 0.25, 0.1, 0.25, right? You'll see how it looks in a second, and then the primitive is the cylinder. So here, maybe I'll save it first. Save it, save it. So now if you go to the thing, okay, well, let's see. Sometimes it'll take a second. We'll see what happened in a second. I'll get back. I'll be right back after I figure out what happened. Alright, I managed to get it working. I'm guessing that I forgot to close it or something like that, but so basically you'll have something like this, right? With an entity with a position of 1, 0, 0.5, for example, color of black, scale 0.25, 0.1, 0.25, primitive with cylinder, which basically creates what comes to look like a hole, right? And we'll just add, 6 of these, right? And then positioned around, so there's 6 of them in total. So you just copy that one, paste it about 6 times. You're not messing with the scale or color or anything like that, but basically just this. So now you have it on this side. You also want it to be one in the center like that. So now you have 3 holes, right? Then you have one like that. So now you have except for the missing one somewhere, miraculously. Okay. Alright. He's somewhere. The hole's somewhere. Oh, here he is. Okay. So now you have 6 holes. So it goes, just different configurations. This one is the x-axis, this one is the y-axis, this one's the z-axis, so whether it's brought forward or not. There's no difference in the y-axis, basically, because, you're not lifting the holes upwards. So there you go, you have... Now you have the holes set up. If my mouse works for a second. Okay, so now you have the holes working, right? So, as in we got them rendered. And then the very last thing that we need to do is we need to render the rodents. Very, very similar to how we rendered these holes. So basically you just create a folder or entity, and we're going to position it at 0, 0.6, -2. We're going to call it the rodents. Close it, right? Then we're going to render our rodent. Mix in a rodent. Then we're going to change some things compared to the original. We're going to change it where the position is 0, 0, 0.5. The rotation, so that faces us as 0, -90, 0. The scale, so that way it's scaled correctly, is 0.05 on all of them. And there we have one little rodent. And then we'll just add 3 of those, and then we shall be good. And we'll just have a couple of them. We'll have one in the center, and we'll have him brought back. And then we'll have one here, and then one here, like so. And now we have 3 rodents. So this is basically all of this A-frame code is basically specialized HTML parsed by aframe.js, right? Basically with the rodents, the holes, the table, camera, and then importing the models, we have the overall aesthetics and all the main components as far as the 3D models and how it's going to be rendered on top of in the world, basically. So in the next tutorial, what we're going to be doing is we're going to animate the hammer and start having it where you can actually whack these mice whenever they're actually popped up under up above the ground, basically. So that's the key component of next session. We're also going to add, probably, if I look up my session information real quick. So the hammer, animate it when it hits a mole. Add the score handler and just programmatically have the reds pop up and down, and obviously have it where you hit the hammer, right? Wax the mole, right? Obviously, we want it to be where it's a little bit difficult, where like you have to like it's difficult but not too difficult. Obviously there's some more fine-tuning to it. I mean, it depends on what VR headset you'll have. For now, we'll have it where if you click on the mouse, or if you click with your mouse, right, I'll trigger it, right? If you have a different controller, like a head-mounted display or something, where you don't have the ability to click or any corresponding action like that, then you can use potentially Fuse, but then there's some timing things that you have to figure out. Because the Fuse has different durations, which means that if you stare at something for a certain duration of time, it triggers the fuse, or when the fuse goes off, which is usually like 1 second or something. That means you have to stare at something for 1 second for it to actually trigger any sort of functionality, right? And that's the key concept of it, right? So I'll go into more detail about the actual whack-a-mole mechanics in the next session. I hope you guys enjoyed this. Please look forward to seeing the next session. See you guys then. Hello everybody, and welcome to the third session of how to create a whack-a-mole VR game in WebVR and A-Frame. So, in this session, we're gonna work on the whack-a-mole core mechanisms. This includes having the rats, rodents, moles, whatever, pop up and down, adding a score keeper text, and then animating the hammer when the moles hit, right? Now, for the score keeper text, let's look that up and see how we do that in the docs. Right. We're looking for a text thing. So basically for scorekeeper text, you have something like this, right? And it just renders the text value and then the value of what it is, right? Well, text is the text, right? So I'll show you what this looks like, and you'll see what I mean. So if we go here into our folder, right? And then we run it with Webpack, and then we run the server. Pull up our server here. So we can see that here's our game, right? But what we want to do is when we go into our code and the index.html, we're going to go like right around here. We'll do score text, right? And then we'll just do that, see how that looks. Now if we go here, let's see where our score text actually is. Elements. So somewhere in the abyss, there lies our thing. Let's look at the code example. It's very important to be able to look at examples and extrapolate what they're trying to do. So it seems that they have some sort of positioning component. Let's see if we can use this as well. See if that works. And there's also a color system. So I guess we can value. So you have value, which is the property that actually renders it. Okay. So we want to do color black, right? And then paste the position. Let's do -2. See how that looks. And there we have our little hello world thing right there. Obviously we want it to be a bit bigger. Probably move it up a bit like here. See. There it is. Not super close. Let's take this and let's put it inside our camera. Okay. And for our camera, if you look at how the hammer's positioned, we just really need to make it like -0.1, and let's see what happens when we put it basically at the center. Okay. Maybe we have to bring it out a bit more. Okay, there it is. There's our little score thing, right? So we'll just we'll bring it up 1, like so. No. Okay, we'll bring it up like that. How about that? No. Positioning is always like one of the hardest things to do, for sure. Okay, there we go. So we should do maybe approximately 0.5 there, 0 on that axis, maybe about 0.25 on there. So about 0.5, so its position is up correctly. So now, if I X this out, okay, that might be something. You have your score, right? I think what we can do, well, what we can do instead is probably position it. Let's see. That's where it is. So we'll do negative 0.25. Okay. There we go. And so basically, it'll just be like that, alright? So there you have your score. That's where the score is going to be. So whenever you view this in VR or whatever, you'll have the score being displayed up there. Obviously, something that we want to probably do is change the font size. So let's see if we can change the scale and how that affects it, right? Should be in a good way, hopefully. There we go. So there's our score, top left corner, right? And right now it doesn't do anything, but we'll get it to do something in a bit. But so that's what will happen. But what we want to do first is we want to actually animate the hammer correctly. So for a hammer, we go here to the where it's the hammer, right? And we're gonna have it where, if I can pull up the what I wrote yesterday. Okay. So we're gonna have it where, okay, we're gonna take this out and just move the scale. Well, the scale is gonna be a little bit smaller, just for simplicity's sake. And we're also gonna change it for, so it goes from 0.5 to 0.25. You don't have to apply this change since it's not really of much. It just changes the size of the cursor. But so we're gonna have it where for our hammer, we're gonna have a animation begin, or no, we'll take that up for now. Attribute is rotation, and it's gonna be duration of 400 milliseconds. And it's gonna alternate direction. You'll see why in a second. Alternate direction. It's going to go from the rotation of 0, 0, 0 to the rotation of negative 90, 0, 0, and we're going to repeat this only once. So it's going to go down, that's the first time, and it's going to alternate it and reverse the animation. So that's our hammer rotation. So now when we go here, alright, so attribute, duration, fill forwards, probably means we missed something. Okay, we misspelled alternate. Alternate has an N. Now, what's going to happen is when we refresh this, it's going to go down and up, right? So that's our hammer. That's our hammer motion. So whenever we're here and we hit the thing, it's going to make that little hammer animation. So for now, since we're not hitting any mice or whatever they're called, they're little rodents, we're going to have it begin when we actually hit a mouse. So it's not going to hit the hammer if it's like there's nothing there. That just doesn't make sense for now. Like we should be like, we're going to hit it when we know for sure, right? And so when this happens, we're going to go in our main.js. Well, we're going to have some logic tied to it. So we're going to put a component to it, and you'll see why in a second. So we're going to have it where it's going to be called hammer logic. That's going to be our component name. So in our main.js file, we are going to have it where we're going to have a component that actually handles this logic. It's going to be called, well, yeah, we'll have this logic. So it's going to be called hammer logic. It's going to be in the components folder. So create a new folder in the JS thing called components. Then we're going to have a new file called hammerlogic.js, right? And in there, we're going to register a new component hammer logic, and on its init, we're gonna have it where it has no rodents for now, and then it's gonna wait for when all the rodents are spawned. And if it does, it's gonna do, okay, if it does get the rodents, or when the rodents do spawn, it's going to call this function upon it, or it's gonna using a special thing from the array class in JavaScript. So basically it's gonna get a list of all the rodents, or all the elements that are rodents. It's going to slice that up, and then it's going to convert it into just a regular array, right? And then there's going to be two event listeners. One is going to be when the animation started. So this is going to be animation start, like so. You want to bind this function to this, and then, well, this one you don't have to, so don't worry about that. And then the next one is animation end, and this is gonna be where it's gonna say, hey, to the rodents, you don't need to actually get killed. So basically for each of the rodents that we'll have existing that don't exist yet, we'll have them do their thing in a bit. Function rodent, tell that rodent that it doesn't have to die since it's the animation, that it can die since the animation did end, which means that we did finally, like, we can hit the hammer again, right? And we'll do that again here, and so that way it can't die. So basically what this whole hammer logic thing does is that we tie this component to our hammer logic. We tie this component to our hammer. When a hammer goes down, it can only kill one rodent. So we tell all the other rodents, hey, you can't die, okay? And then when the hammer is lifted and the animation has ended, we say, hey, now you can kill other rodents. So the rodents don't get killed when the animation's going on, pretty much. So it's only one rodent gets killed per hammer swing, right? That makes sense. So now if we go to our code, it seems to be working fine. There's our hammer logic, and this gets imported into our main.js. And if you look at where was it? If you look at where we have our webpack right here, you can see that, okay, can't resolve components hammer logic components. There we go. So now if you look at it, well, this actually will show us in here, right? Maybe not. Oh, it's only calling one function in the here, so basically you don't want a semicolon when you call a function from the slice in the array prototype that JavaScript provides. So when you do that, everything should format correctly and it loads everything in. And we look at our A-frame, it looks fine. So next thing we want to do is we just want to have the overall be able to display the score, right? So in order to do that, we have to have a state component, or a state handler, and then we have to have let me check the documentation for that real quick. So we're doing A-frame state. Yeah. So you have a state container, and then whenever we want to receive it, we just do, you just bind it. So for this one, you just bind text, right? You say the value is app score, right? So we can just take this, or we can do the entity bind equals text.value in the score, right? Or, I mean, it makes sense. You're just binding it. What we'll do is we'll declare that state container in a file called state. So we're going to require it first, then we're going to create the file, call it state.js. But before we do that, we have to actually import it in. So if you go into index.js and you see here, we only have A-frame. Second thing, we actually also have to get our regular script in. So we'll just do script source and then this, what is it? Because that's why our stuff was working in the first place, since we are adding stuff in there. So you want to import that script. This is A-frame. Then you want to import the state container. And state container will have, you just go here, you go to GitHub, go to components, go to state. So you want to go to kframe, and then inside the components you'll have one called state. You go into this, you go to this one, you copy the link to this one, you go to raw git. This is where you can get the specialized things for it. You paste the URL there, you do the one, you copy this one that they save for development, then you just put that in as a source tag, like that. So now if we go back, hopefully we shouldn't have any errors, but I may be wrong. Okay, no errors, so we have everything loaded. Then if you look at our sources, it says that we have loaded in main.bundle.js, right? So that's perfect. So what we'll want to do is inside our state, we'll register it like this. We'll do A-frame register state, and then we're going to do the initial state score is of 0. The handlers are of like this. We'll have one that decreases the score. This will be a function that takes in the state and the action. Then we'll have a second one that increases the score. This one will take the state and the action as well. And all this does is either takes a score, adds the points from the action, or it takes a score and it subtracts the points from the action, or the score. Subtracts the score with the points that are attached to the action that we're issuing, right? Like that. And then if we go here, we go into our index.html, what we should be able to do now is back in our camera where we have our score text. This is, we'll just say cursor ring for that. What we can do is we can take our score value, right? What does this say? Oof, we forgot that. So make sure that you don't have any errors in your JavaScript, because that's bad, because you don't want errors. Okay. So once you have like 0 errors in your code, which is always something you want to strive for, and here we want to bind our score, right? So if we go here to the A-frame, go back to this documentation, right? And we see the to bind it, we just do this. We just copy this one because this is for a text. Or we do this one. Well, we'll try this one. Let's see how that goes. Oh, well, there might be some other things. Okay, what about bind? Okay, so bind the state like this. Go here, you paste this in. We'll paste this in, because this apparently seems better. Yeah, paste this in, and disregard that. So this will take our text component there and bind it. Now if we go here, it says it's 0. Obviously you want to add a little bit more fluff to it. I don't know exactly how we'll go about doing that, but we can try. Let's see what they say. To bind expressions, bind equals. So we'll just have it like, here, we'll have it like this. Because that makes things easier. We'll just take that here, right? Take the position as well. Then we can just put that there. And then that should be to the same effect, I suppose. Right. So then, all we have to do is add a second one. This one just has text, same thing. Color is black, but the value is score, like so. I believe. Well, we should be able to pull that off. Yeah. Right? And then all we have to do is take this one, 0, 1, 0, 1, 0, 1. That's a little bit obnoxious. Okay, we'll just do this one for safe measure. So now it'll take our score and render it there, right? Obviously it doesn't look the best as far as positioning goes, but it'll work for now. So whenever we change our score, so if we go into our state and we change it to say 1, then it'll change correspondingly. And it should also change in response to what happens to it. So what we want to also do, since after we've done that, we've done this score part of it, which is the most key part. What we want to do is we want to handle being able to spawn rodents in, right? And in order to do that, we'll have a file or a script called rats, and we're also going to have an additional script called holes. I'll show you what we'll do in the holes thing. This is just going to be able to like handle the generation or where it's going to be positioned. So we're going to have a small helper function called create position. Takes an x, y, and z. It's going to return for us a x, y, and z using the ES6 helpers or new syntax. And we're going to have a new constant called hold positions, and it's just going to be a list of hold positions at 1, 0, 0.5, it's 0, 0, 0.5, etc. So I can just paste these in. Now we have 6 hold positions, and then in our rat script, what we'll do is we're going to actually just create a simple function that creates a rat for us, right? And it'll take in a position as the variable with the specific format that we mentioned before. So we'll just create a new element, call it rat, using just the regular vanilla JavaScript create elements. Make it a entity. We're gonna have set the attribute where it is a mixin, and it has rodent property for the mixin. We're gonna have it set the attribute for the position, and that'll just take in the position, right? And then we're gonna set the scale. So we'll do set attribute scale, take an x of 0.05, y of 0.05, and a z of 0.05. And then we'll set the attribute of a rotation to be x of 0, y of -90, and z of 0. And then we're gonna have it have the class of rodent. And then we're gonna just return this rat. So that's the rat script for it, or the main script, that function that creates the rat. And if we go back to our main.js, we don't have anything referencing to it, but we're gonna have an additional component that's just is gonna be our world component, and that's gonna handle everything that we're doing from a high-end level to the world, right? So we'll create a new component here called world.js, and we're gonna import it here. Like so. And just to test it, we'll say the world, right? So when this actually loads, go in our console, it says the world, so we know that works. And this will be like the other ones, but we'll import two things. We'll import create rat from the rats script that we created, and then we're going to also import another one, which is the whole position. So that's where we can actually spawn the rats, and this will be holes, or whole script. So then we're going to actually register our component. We're going to call it world. We're going to give it a schema of like nothing. Schema doesn't matter for now. We're going to also create some empty functions. Spawn rodents. And then just a tick function, which will take in the time and the time delta, like that. Okay. So when we load the world, we're going to start with a time of 0. So that's only for spawning stuff. I'm going to say that the world was loaded. And then we're going to spawn the rodents like that. So then in our index.html, we're going to make the scene, the root scene, a.scene to be of component world. So now when we go back here, it'll say that the world was loaded once again. Just to check that it's different, we can just add a couple minus signs, and it's different. So perfect. So now we actually have to add the ability to spawn the rodents in, right? So we'll access the, if we go all the way down here, first we're gonna delete all these rodents, we don't need them anymore. We're gonna access this element by the rodents ID, right? So we go here, we can do document get element by ID, and our ID for that specific container is rodents. And we're gonna just take all our hold positions, right? For each position, we are gonna take a rodent, and we're gonna create the rodent at that position. Then at the rodent's element, the parent one, we're gonna append that in, like so. And then we're gonna get the hammer, document.get element by ID, and this will be player hammer for the ID. And then we're gonna tell the hammer that, hey, all the rodents spawn. So now you can keep track of those, right? Obviously, if the rodent doesn't exist anymore, that sucks to be the rodent for sure. So, right. That's what else? Okay. For the hammer here, I would say we can just create a function here. Yeah. We can call this function get rodents. That's it. Yeah. This is just a helper function because I want to take this and copy it, put it here, right, like that. So instead we can just do get like that. Okay. So in our world, we spawn the rodents. If we want to actually see this in action, if we check here, well, we have an error, cannot read property emit of null. So that means that if we go in our index.html and we go to our hammer, we did not give it the appropriate ID, right? We didn't say it's the player hammer, so we'll just give that ID right now, player hammer. Now if we go back, now we have all these glorious rodents here for us, right? Now, if we go back to our rodents thing, you can see that we added a, if I'm not mistaken, let's see. Oh, in our mixin, we're gonna add something for the rodent so it can handle some behavior for us, right? So if you go into the mixins, here's our rodent, right? We're gonna add a, not a mixin, we're gonna add a component to it. We're gonna add a component to the rodent called rodent logic. We're gonna create a corresponding file for that. Logic.js. I'm going to import it from here. So now we have that. And then we'll just do that. And so what the rodent logic allows us to do is basically it allows us to see if the hammer or if the rodent has been clicked on. If it has, then the rodent is gonna die, sadly, and so amongst some other things, obviously, but that's the key thing of it. So we're gonna take that, register the component, take the rodent logic, name it rodent logic at least, have it init function, have it have a, what other functions are I'm gonna add to this? I'm just gonna have a tick function. This is for its popping up and down behavior. It's going to have an update function. Well, no, we don't need that. Okay. So in the tick function for the popping up and down, well, we'll move to that when it comes time to, but we're gonna have it where this dot time is equal to 0, this dot random interval is equal to math dot floor, and then math dot random times math dot floor 3000. I don't see why we'd have to do that, but let's just keep it that way for now. So what this does, and we'll say that it can die for now, and you'll see what I mean by this in a second. And we're gonna add an event listener to this called switch, and make sure this function is bound to this, and get the attribute of visible, which is a boolean, and then set the attribute to be the opposite. And then in our tick function, to actually implement this switching behavior, we'll increment the time by time delta. We're gonna check if this dot time is greater than the random interval that we selected, which is beyond, like, between 1000 and 4000 milliseconds. And if so, we're gonna emit that it can switch, and that the time has been reset to 0. So that means it's gonna switch in the next interval after when the next interval passes. So now we have the popping up and down of these rodents. But the thing is, we can't click on them yet, right? We can't hit the rodents. This is a whack-a-mole game. We gotta be able to whack them, right? So we're gonna add another listener. We're gonna add a helper function called hammer hit, and inside this function, it's gonna get the the parent of everything, which is just this one, or, you know, like that, get element by ID, right? And if it can die, right, then we remove this element from it, and then we tell the state container, the way you access it is doing a frame scenes, access the 0th element, and then you do increase score, and then the action itself. In this case, for this one, we're doing 1 point, so do points 1, and then we're going to tell the hammer that, hey, now you can hit. Well, we'll tell the hammer that it's going to be able to hit either way. Well, yeah. And so we can say hammer.emit hit. So, and it can die. So, and we'll have two functions here, this empty space, where if it can or can't die, you know, that will depend. But for now, it can die all the time, so we'll just hit these, or try to hit these. Get rodents is not defined. Get rodents is not defined. Okay, so if we go into our hammer logic, it's like, hey, get rodents is not defined, right? So go in here, we have to do okay, this dot get rodent, so it knows what we're referring to, and we want to bind this function then, like that, because we're referring to something from this. So now when we do it, query selector all is not a function. Oof, okay. Where is that? Okay. Query selector all. Query selector all is not a function. Okay, you have to spell it right. So now if you go back, refresh it, query selector all is not defined. Okay. Query selector. You have to make sure that it's actually tied to the document correctly. There you go. So now you can actually, with some effort, some zeal to it, maybe. No. Let's see. Okay. We want to check. Well, we actually want to handle this function. So basically, in order to actually trigger if the hammer was hit or not, we have to add 2 new listeners. Mouse down, have it taken hammer hit as the function, and then click, have it taken hammer hit as the function once again. And now, this is the lucky one. Now you can actually click, and these ones should die in theory, right? Well, in theory it should. Let's see. Can die. If it can die, which is a function that we emit, then is equal to true. I want to bind that as well, and then do this one where it can't die, or it won't die anymore, and that means that can die is false. Bind that. So in our hammer logic, we have it where the animation is ended, it can die. If the animation is started, it won't die, or don't die, right? That means it's false. So now if we do it, let's check our errors. That's probably why the error stuff hasn't been, okay. Okay. You can't do that because I expected a comma for some reason. Comma. Pretty sure it has a comma. Let's run the pack again, see what's up. Okay, that compiles right. So now we hit this. Well, they're not dying per se. Maybe not. Let's see. happens when we do this. Oh, we haven't bound the function, that's why. So when you bind this function as well, then all of a sudden things can die. And the score actually, so now we actually want to incorporate that function I told you about. Okay, so in here, between here and here, you want to add one event listener, like so. Checks if it can die, and if it can, then this that can die is set to true. You want to bind that to this, like so, without the semicolon. Then you want to do the same thing for the other one, where, hey, if it tells us that we can't die, then, you know, or we shouldn't die, don't die, do the same thing, but set it to false instead. Like so, right? Now, once it starts, it's pretty nice. Well, there's a little bit of a buggy situation to it, since some of them are a little bit spicier than other ones are quicker. But yeah, so once that happens, it's essentially, here he goes. Okay. So now that's pretty much like core functionality down. What we basically did with that is we had it where, you know, we have a rodent logic. We set up a time where they spawn at or they pop up and down at random times, and then we have it where if you're hitting the hammer, you can not die, and if you're not hitting the hammer, then all of them can die. And if they can die, then we say, hey, you know, do the hammer animation. But if they can't die, then, you know, don't do the hammer animation, because we're already doing that right now, right? So what we also want to do is that when we finally, in our world thing, right, once we finally have it where all our rodents are dead, they're all dead, right? What we want to do is we want to have it where they all respawn, right? So we can get all the rodents from query selector all, and then do just where they have the class of rodent. And then if the rodent's length is less than or equal to 0, which means we have not any rodents, take the time, increase it by time delta, so the time that we set up here. If that time that we just increased is greater than or equal to 1000 or 1000 milliseconds, set that time back to 0 again, and spawn up some new rodents. And initially, all the rodents will be able to die, right? This is exactly what we wanted to do. So now if we go here, kill this one, this rodent, this one, this one. Ah, this game is even hard for me. Okay. And after that, they respawn again. And they just keep respawning without end. So basically, that one was a little bit confusing because it's a lot more, that's the one with the most logic, obviously, right? But basically, quick rundown, since this was a pretty long tutorial. You have three components that are tied to things. You have the world component, the rodent component, the hammer component, Then you have some helper functions in holes.js, rats.js, and then state.js. State.js is state container. Then all our rodents are being spawned here upon these positions above the holes. And then our state is being updated to increment the score whenever we kill the rodent. So that's that for this tutorial. Sorry if it was a little bit more disorganized than usual. There were a couple issues that or bugs that I ran into that I had to really think through and just double check to see why it was doing that. So that was our third session. For the fourth session, we're going to actually add a game timer so it's not like without end, and then we're going to have it where the user is presented with how many rodents he actually was able to hit once the timer has ended, and then we'll add the ability to just reset the game or the timer. Let's just start over, right? So we just reset the score to 0, spawn up a bunch of new rodents, and there you go. So that'll be the final session. It's probably not going to be as long-winded as this one. This was like pretty much the core meat of it. If you guys enjoyed the session, please be sure to watch the next one and subscribe to this live EDU tutorial, because I will be producing more and more tutorials as time progresses. Hello, and welcome to the fourth session of how to create a whack-a-mole VR game with WebVR and A-Frame. So, in this session, we will be adding, we'll be just finishing up the game. So we're going to be adding a game timer, presenting the user with the moles that he has hit after the timer finishes, and then adding the ability to reset the game or timer and start over, right? So, first things first, we are going to try adding in the game timer. So we're gonna create a new component and we're gonna call it timer view. But first we're gonna create the actual element itself that's gonna be displaying the timer of the game. It's gonna count down, say, from like maybe like 30 seconds or something. So timer view, and we'll have a scale of 2 to 1 like all the other ones. We're going to position it as 1 at 0.075, -1, and then we're going to have a component tied to it called timer view. And the text is going to be initially of the color black. And then we're going to close this. So we'll have in our JS folder and components, we're going to have a new file called timerview.js. We're going to import it here. And the path is going to be ./components/timerview, and we'll just copy something like this and then paste it here, and then we'll delete all that for now, and we're just going to call this timer view. And initially, just for testing purposes, inside the init function here, we're going to have it be where it sets the attribute text value of just, hello world, right? So we're going to kick up the Webpack for the VR, and then we're going to kick up the server so it actually renders a server out for us. Slowly but surely. Let's see, cannot read type property VR, whatever. Okay. I wonder why it's doing that. Okay, let's do a little bit of debugging. See why it's saying that. Because these bugs happen on occasion, so. What about... What if we do this just to see what happens? Because it should work. I don't see why it's not working. Oh, we can just do this instead, and that makes it easier. So we can just install A-frame like that, and just that way we don't have to worry about it. Or 0.80. What version we have? 0.80. I guess, you know what, let me run this in Firefox and see what's up. Because that might be an issue. Yeah, so something with the new Google Chrome probably has messed it up. But, so I would keep that in mind that VR.render. Yeah, I think that's just some bug that they have right now. So we'll run it through Firefox. Okay. Alright, sorry about that. So, now we're ready. Okay, so score right now is 0, right? Now we can actually add the stuff in. So time review, right, which needs this, which is here. So now it says hello world to begin with, which is fine. That's what we needed to do. So right now that's what it's doing. What eventually we're gonna have is gonna have a tick function. Takes some time delta. It's gonna get the world document query selector, and that's gonna be a scene. It's gonna get the game time and if the timer is ongoing, which is just attributes from the world that we're going to add. And then going to have a thing called pretime, which is basically math.ceiling. So like instead of floor it, round upwards. It's going to be the game time divided by 1,000 because the game time is going to be in milliseconds. If the timer is ongoing, then we set the text attribute to pretty time, and if not, we just say that the timer has ended. So since we don't have any of that stuff, it just says timer ended. Because if we go into the developer tools, go into the console, yeah, it doesn't have that. So then we go into our world and we realize that, okay, so now we need to get the timer itself and then if it's ongoing or not. So in our world component, we're going to have to modify the schema so that it has those two properties. So game time, which would be of a type float, and it's by default it's going to be 0.0, and then timer ongoing, this is going to be a boolean, and this is going to be true by default. And then our init function, we're going to have it where we set the initial game timer, and we set that to be, for the world component, getting game time 30 seconds times 1,000 milliseconds, so 30 milliseconds, 7,000 milliseconds, giving us 30 seconds. Then we actually start the timer, this.l.set attribute world timer ongoing true, and then that's that. So that means that when we're in our tick function, all right, we're going to get the previous game time, and if it's ongoing, when we retrieve the attribute from the world component, and then we're going to let the updated game time be the game time minus time delta. So that's like the difference between each, the time elapsed from each frame, right? And then we're just gonna, if the timer is ongoing, right? And then if since we don't want it to go forever, we want to check that it's greater, that when the timer hasn't gone below 0. So if that's greater than or equal to 0, then yeah, we're gonna do, we're gonna update the game time, so it's the updated game time. But if it isn't, then we're gonna update the timer ongoing so that it's just false. And that should be that for now. And then we stop respawning rodents if the timer is not ongoing. So now we have our timer right here. So now it doesn't do the, so it doesn't spawn any new rodents. So that's the first part. That's us handling the adding the game timer. We have rendered the time, but now we want to present the user with the moles that he has hit after the timer finishes. So one thing we definitely want to do is we want to kill all the rodents once the timer is not ongoing anymore. Well, yeah. Here. Okay. Right. So if it isn't, if the timer ongoing is false, then we want to kill all the rodents by using this function, right? And then we want to show when text. So we'll have show when text as a function. And we'll also have hide when text as a function. We'll also have kill all rodents as a function. So for kill all rodents, we're going to get the rodents container, which is just the one that has the element of rodents. We're going to get the actual rodents inside there. And that's the ones that have the class of rodent. And then for each of these rodents in here, we're going to remove them from the container. So say we do this to 5 seconds. So 5, 4, 3, 2, 1. Then all the rodents are killed for us. That means that, you know, we can't get them back until the game resets. And when that happens, we also want to show the win text, right? But we don't have a win text element set up yet. So if we go into our index.html, we're going to have it in our UI again, very similar. We're going to call it win text. It's going to be formatted a little bit specially, but you'll see what I mean in a second. Make this 221 as well. Set the position to be equal to 0.45, 0.25, and then -1. Close that, like so. And initially we're going to have one that has a text of color black, value of something. This one's going to say you killed, and then so you killed and then blank, right? And then right next to that we're going to have another text thing, a text object. And this one's going to say, well, this one's going to actually be bound to our state that we set up previously. So this will have the position of 0.27500, text equals color black, right? And then bind equals text value score. So that means that this is bound to our score state, basically. And then the final thing is just the word moles. This is also a piece of text. And this would be color black and then have the value of moles. So when we look at this in our game, this is what it is, right? That's what happens. It presents it to us when we win the game, right? But we only want it to present to us when the timer has ended. So instead, in the world JavaScript, we're going to have it where it's going to hide the timer. No, it's going to hide it. So when in our tick function, right? No, in this tick function, when the timer ongoing is true, then we're going to hide this win text like that. So we need to actually implement these two functions. So we're going to have win text be the document with the ID that we gave it, which was winning text. All right. Then we're going to have it be visible by checking its visibility. So if check its visible component, or yeah, that's what it's called, or the attribute visible. And if visible is equal to true, right, then we're gonna just set it to false. And this one is essentially the same as that one, but the difference is that we take this one, check if it's false. If it is false, set it to true. So now it won't show us our score until we lose, right? But in this case, now we have to reset the game, right? That's our final and last thing that we want to do. So what we need to do when we reset the game is we need to reset the score, right? Then we have to spawn in a new set of rodents. And then we have to reset the timer. 3 things, right? So what we have to do is go into our state and create a new thing for that so it can reset the score. And this will just be called reset score. Take in state into action, and it's just gonna say take the score and set it to 0. Right? And then back here we're gonna create a new function. We're gonna call it, we'll put it right here, we'll call it reset game. And when we reset the game, we're gonna get if the timer is ongoing. We're gonna get the attribute of world, And then if the timer has stopped, right, then we're going to kill the rodents first when we reset it. We're gonna reset the score by emitting a new action, and we do this through this method. And then reset score. In this case, there's no real payload, so we can leave that this. And then we're gonna reset the timer. So we can just do that by taking these two right here. And then when we reset it, the rest should take care of itself. But in order for us to trigger this function, we have to add an event listener. And in this case, we'll add it right here. And we'll check if it is clicked, and if it is clicked, then we're going to reset the game. And we're going to bind it to this so that way it functions properly. And so basically, we have this listener, it's always listening, but it only triggers if the timer has ended, because we wouldn't reset the game if the timer hasn't ended, especially if it's the click one, right? So now if we go back, when you ever click, it starts the game up. You can hit stuff and stops, and then after a while it'll reset again, obviously, because of the focus thing. That is another issue, but that is something that can be figured out pretty easily, but that's not really within the scope of the tutorial. Now if you do want to figure out how to make it where it's only mouse click, I would do something maybe like mouse down, right? And now it only works when you do mouse down. So that's how you would solve that small issue. But it really depends on your interface. In this case, we're assuming that the person has like some sort of mouse or something that's equivalent to a mouse that can simulate, you know, a click, right? Something like that. Obviously, these certain events like on mouse down, mouse click, focus, those are dependent very much so on whatever virtual reality headset you're using. In this case, I'm running it through the web browser, so they can use their keyboard and their mouse as a secondary controller to their headset. And other headsets come with different controls, but that was basically that. There is a fully functional Whack-A-Mole game. Now obviously we want to change this to 30, so that's actually a playable thing. But besides that, you know, it's fully playable. It's a Whack-A-Mole VR game. So I'll be uploading the project resources to it, so you guys have access to source code on LiveVDU. But besides that, I hope you guys enjoyed this tutorial. Please look forward to seeing future tutorials from LiveVDU and me on the site. So see you guys.